Alright guys, and we're back, and this time we'll be looking at how to resolve forces on smooth inclined planes. Okay, so what you need to know, we need to know when to include additional forces on this diagram, such as weight, perhaps tension, we're going to focus on that next time, normal reaction, and eventually friction. Thankfully in this case we'll be looking at smooth, so smooth does not have any friction involved. Well, without further ado, I'm going to jump straight into an example to really explain this in an easy way. So, first of all, let's have a look at the sentence and try and draw as we go. So we have a mass of 5 kg which rests on the surface of a smooth plane which is inclined at an angle of 45 degrees to the horizontal. So what does this mean? So if we're going to draw a diagram, a simple one, so I recommend you do this as we go, and it's going to be inclined 45 degrees to the horizontal, and then we know that there's a mass which rests somewhere on this surface. Here we have to give a weight all the time, and a weight to this one it will be 5g, where g is a gravity component, which is valued at 9.8 meters per second squared. So it's a gravity of the Earth, a constant gravity. Okay. Now, in this case, when we have a weight going down, there's always a normal reaction which is perpendicular to the plane. It happens in every case, and never miss this. So it's perpendicular, and we call this one R. Okay? Now, what else do we know? We also know there's a force of P newtons acting horizontally on the 5 kg mass. So when it's acting horizontally, that literally implies that there's a push over here of 5 newtons. Yeah, we call it 5. Sorry, we call it P. I don't know where I got 5 from. So here, the push of P newtons. Okay, now, and hence is in equilibrium. So this is quite important. So this implies that the whole force now, the whole system equals 0. So this is force equals ma, where there is no acceleration. Now all we have to do is calculate the magnitude of P and normal reaction between the mass and the plane, which is R. In other words, we have to resolve. So how do we resolve this? Well, first things first, it would be best to label every angle. Okay, so get my blue pen. Knowing that this is 45 degrees, I would draw an XY plane, because since we're working horizontally, we know that if this is 45, then the Z rule from GCSE will tell us that this is also 45 degrees. Hence, this part is 45 degrees, and this part is 45 degrees. That's it. Now we just resolve. So first things first, let's resolve vertically. In other words, upwards is our positive. Going upwards, we know that there's the reaction which is bent to the left a bit, but on the vertical line is 45 degrees, so we use a causal rule, which is R cos 45. And then there's no forces, but then going downwards we have 5g, so it'll be negative 5g because going downwards. And as is in equilibrium, equals 0. And that's it. And then if we resolve to the right, we can see that we have nothing here, but here P is going to the right, perfectly to the right, so it'll be just P, no angle. But R is bent to the left and is negative, so it's facing the opposite direction and it's angled at 45 degrees, so it'll be R cos 45. And again, we ignore 5g because it's vertical, we just want horizontal, and we equal 0. And that's it, guys. Now you just solve for this. So here we make R the subject because it's easy to solve. So using the first equation, plus 5g across and divide cos 45, we get this. And what does this equal? Well, I'm just going to whip this out my calculator. We've got 5 times 9.8 over cos 45. And this, my friends, will give us 49 root 2 or 69.3 newtons. Easy. And of course, using this and making P the subject, we're going to have P equals R cos 45. With R being 69.3, hence smashing the calculator will give us 45. And that's it, guys, 49.0 newtons. And that's it. So really, this is how you resolve a simple smooth incline, system. There's, of course, sometimes we might include something like tension over here, and then I don't know, probably some friction, but then this would have to do with another type, which is called rough inclined planes, but we shall get to that very soon. But anyway guys, adios, and catch you all in the next video. Ciao.